wanting. The only thing I forgot to put on here was that I have a journalism degree. So.
Okay. Ladies and gentlemen, welcome to the third Thursday lecture series. This month's speaker is Laurel Kornfeld, a freelance science writer and amateur astronomer who reports on astronomy and space for various websites including Spaceflight Insider, for which he covers the New Horizons mission, and Space Reporter. Her articles have also been published in The Atlantic, Estella d'Alva, the newspaper of the 2009 IAU General Assembly, the UK Space Conference, and Astronomy Magazine's blog. She started her own Laurel's Pluto blog in 2006 to present scientific arguments against the IAU planet definition and subsequent demotion of Pluto. Laurel has done several public presentations on the subject of Pluto, including one at the 2008 Great Planet Debate, held at the Johns Hopkins University Applied Physics Laboratory, that's JHUAPL, in Laurel, Maryland, in response to the 2006 IAU vote. She attended a 2013 Pluto Science Conference at JHUAPL, that's JHUAPL, as well as the Pluto Flyby celebration there in July 2015. In 2011, she obtained a graduate certificate of science in astronomy from Swinburne University's Astronomy Online program. This year, she celebrates a decade of membership in the Cranford, New Jersey-based club Amateur Astronomers Incorporated, AAI. Laurel is also an actress who has performed in various plays and independent films, sometimes as zombies. And you have a journalism degree?
Yeah, bachelor's in journalism.
From where?
Rutgers. It was Douglas College. Now they're all one university.
Okay. Is that the Rutgers campus in Newark?
New Brunswick.
Oh, New Brunswick.
Yeah.
Where's the main Rutgers campus?
Well, I thought New Brunswick was, but there's one in Newark and Camden also. So.
Oh, I'll have to look it up. But
look it up. Yeah, that was a while ago.
But right now, let's focus on Pluto.
So as you can read it, right? Pluto is. I find Pluto fascinating. I want to thank everybody for coming, Chris, and say that I'll take questions and answers at the end. But if you have something you don't understand and you want to know what it is, please ask. It's I'd be happy to answer. Otherwise, save the questions for the end. And if Pluto has confounded expectations throughout the 87 years that it's been known. Now I'm fascinated with Pluto, and I used the subtitle "Something Wonderful" because Alan Stern, who is you'll hear me mention him a lot, the principal investigator of NASA's New Horizons mission to Pluto, when he was asked before, years before the flyby, what do you expect to find at Pluto? His answer was always something wonderful, and it certainly was. And Pluto has really always been it's like expect the unexpected. You never know what you're going to get. Next slide. Okay, so I started with this little cartoon here, which Chris found. Thank you. Which, of course, everybody, and I'm going to talk a little bit about the planet definition issue, but I want to talk more about Pluto's history. So this is Pluto, telling off the sun, based on that whole demotion. But here you have, it started with X. X is a mathematical term for the unknown. I'm not a mathematician, but whenever there's an undiscovered but theorized object, it's usually called planet X if they suspect it's a planet. And beginning in, Uranus was discovered in 1781. It was the first planet ever discovered in modern times. And scientists plotted an orbit for it based on its mass and its location, and found out after years that it didn't follow the orbit it was supposed to follow. The difference was called residuals. Why is it not taking the path that we calculated? So scientists were thinking there's another gas giant behind Uranus. And they basically they calculated mathematically from these residuals where the planet is and discovered Neptune in 1846. And that kind of really starts the search for X. So, you want to go to the next slide? Okay. So, Neptune had the same thing. That people noticed that an orbit was calculated fascinated, but it wasn't exactly following that. So immediately the thought was another gas giant. There's another one. That's Planet X. And there were all these searches, astronomers searching for Planet X. One astronomer was searching, called it Planet O, and then he proposed there were 7 planets behind Neptune. His name is William Pickering. But the person that really became dedicated to this was Percival Lowell. He was a mathematician and an astronomer from Lowell, Massachusetts, which is, the family goes back to the Pilgrims. They're very wealthy. Poet Robert Lowell is from that family. And he built an observatory, the Lowell Observatory, in Flagstaff, Arizona, in 1894. Originally, he was studying Mars, and he wanted to prove that the channels seen on Mars were built by intelligent civilization, people there, beings. And he wasn't taken seriously by other scientists, and that didn't go well with him. So at some point he said, I want to look for Planet X. And that became around 1905, that became his project. Now what's interesting with Percival Lowell, and here he is, this is him at Lowell Observatory, is he didn't find Pluto, but he kind of did. He died in 1916. And remember, he's looking for a gas giant. He was taking all these photographic plates from different parts of the sky, comparing, those taken one day to those taken, a couple days later to see what moved against the background stars. Well, because he was looking for a gas giant, he never knew. What was found out later is that Pluto does appear on some of his photographic plates taken in 1915 and 1916, but he didn't recognize it for what it was. A lot of times after discovery, scientists will go back and they'll look at earlier images. They call it pre-covery images. We're like, oh yeah, there it is. No one saw it. So he kind of did find it, but he was looking. He didn't find a gas giant, so that little thing he didn't know that was Pluto. Next slide. That's Lowell Observatory. It's still operational over 120 years later. There was a 13-year gap after his death because his wife, Constance, contested his will. He left her enough money, but he also left a lot of money to keep Lowell Observatory going, and she contested that. So while it was in court, the planet search was kind of in abeyance. Nothing really happened. Next slide. Okay, so in 1929, 28, 29, it was decided, I think it was 28, it was decided, the court decided in favor of Lowell Observatory, and the search resumed. And what happened was, this is Clyde Tombaugh. This is the man who actually discovered Pluto. He was a 23-year-old high school graduate. He did not have a college degree. He was a farm boy from Kansas, but he was extremely intelligent. He was an amateur astronomer since he was a child. He built his own telescopes, sometimes out of parts of farm equipment, out of a part of a lawnmower, out of a part of a Buick, and he used some of those telescopes his whole life. And he observed, he had dark skies there in Kansas, and he observed Mars and Jupiter and drew images of what he observed. And he wanted to send them to an observatory for feedback. The only observatory he knew of was Lowell Observatory. So he mailed them pictures of his drawings. Well, this just happens to be at the time that the search was resuming. I did want to add, I forgot to mention, he taught himself trigonometry for fun. So yeah, so he's a really smart guy. So and they get this, and they're like, this is the perfect person to do the planet search, because basically he's young, he doesn't have a degree, he doesn't have an agenda of his own as other astronomers would, and he'll probably work for low wages, and they saw he was intelligent and they hired him. He didn't even have, they wrote back to him in response to his drawings, offering him a job to find in the planet search. And he didn't even have enough money for a round-trip ticket to Flagstaff. He had a one-way ticket, left when his mother was pregnant with the sixth child. Okay, go to the next slide. Okay, I'm sorry, just go back for a minute. I just want to say, I'm going to talk about the blink comparator. The other one. No. Yeah, there he is at the blink comparator. That's a mechanical device that's used to, where the photographic plates were blinked. You would put the two taken of the same part of the sky, different days, together and blink back and forth between them to see if anything moved. And there's so many stars on them, you really need a very good eye. Very few people would find this. And that's what he used. Originally, he was not supposed to do the blinking. He was supposed to they got a new astrograph, a telescope with a camera. He was supposed to take the images. And the images can only be taken about 2 weeks of the month because the full moon washes out the sky. So when the moon was full or close to it, he couldn't really take any images. But eventually the observatory had him blinking. They had him doing various manual labor tasks. They had him shoveling snow. There were times when he was blinking in the day and observing all night, and it was cold. Next slide. This is him with one of those telescopes built with farm equipment. This is him when he's like 90, and he still used it. It's still at the Tombaughs at his family's. His family's now in New Mexico. So and in fact, he had another offer to be a telescope maker, but he went to Lowell, and he decided to join the Planet Search. I think one thing that's really interesting is that both Clyde, talk about popularity. Pluto's very popular. Lots of people seem to like Pluto. And both Clyde and Pluto are underdogs. Clyde was a guy with a high school diploma, and he found a planet. Within a year of being at the observatory, on February 18th, 1930, next slide. Yeah, here's the blink comparator again. He discovered a planet using this. He was blinking. This is a close-up, and there's a picture of the Pluto discovery plate there and a picture of him. He found it with blinking two plates, one from January 23rd, one from January 29th, 1930. He found it on February 18th, 1930. Next slide. Now, this is the discovery plate. So there's January 23rd, there's January 29th. The arrows weren't in the original image that he blinked. And they show how it moved against the background stars. It's so tiny and so faint that, I don't think I would have found it. And just to do this and go through all these plates, it's amazing. So these are the Pluto discovery plates. Copy of them is on display at Lowell Observatory. And actually, the next one, the animation, you can actually see an animation of how it moves for between those 2 days. And I think Chris said he saw other objects that move on there. So they could be asteroids. I don't know. I'd have to look into that. But that's Pluto. Now the controversy about Pluto didn't start in 2006. It started in 1930. Next slide. Oh wait, no, you skipped. Yeah. So here's a cartoon from 1930. The stork delivering another little planet, a newborn planet, to the sun and the other planets. But the controversy began immediately because remember they're looking for a gas giant, and of course as soon as it was discovered, the observatory delayed announcing it for a month while they wanted to confirm that yes, it's there, it's a planet. They couldn't resolve it into a disk. Planets are round. Stars are spherical, but they're so far away they just look like a point of light. Well, they couldn't resolve it into a disk with the most powerful telescopes. So immediately, astronomers started saying, wait a minute, maybe it's a comet, or maybe it's the moon of a bigger planet, except no bigger planet was found. It was determined to have an eccentric orbit that's tilted about 17 degrees to the plane of Earth's orbit, which is called the ecliptic. The ecliptic is not the plane of the sun's orbit, it's the plane of the Earth's orbit. But its orbit is stable. It's not going to bump into Neptune, it's not going to fall into the sun. It's a stable orbit. And what's interesting is that the press release did not even mention Tombaugh's name. The Lowell Observatory played up Percival Lowell, big time, you know, and they just wrote a junior astronomer discovered a planet. He really, this is Clyde, you know, the underdog. He really didn't get the credit at the time. I mean, not enough from the Lowell Observatory. And if you notice, it wasn't the IAU that announced the discovery. The IAU is the International Astronomical Union, which was founded in 1919. Back then, they were not interested in planets. They really dealt with stars, galaxies, cosmology. So the Lowell Observatory announced it. Next slide. And they picked a very specific date. They announced it on March 13th, 1930, because March 13th was two important anniversaries. It was the anniversary of the discovery of Uranus by William Herschel in 1781. It was also the birthday of Percival Lowell. And again, they were hyping Percival Lowell big time. So that was the day it was announced. And Pluto has all these interesting characters associated with it. One of them is Venetia Burney. So she's this girl in England who, her great uncle named the two moons of Mars in the 1870s. His name was Henry Madden, and he named Deimos and Phobos. Her grandfather was head of the Oxford Bodleian Library. And the day after they announced, you know, a new planet was discovered, was announced, he read the paper at breakfast, and the discussion came up about what should we call it? And her grandfather's name was Falconer Madden. You know, I guess he was very, you know, encouraging of academics in his granddaughter. And 11-year-old Venetia Burney said, well, why not call it Pluto? And she was a fan of both astronomy and mythology. And she thought of the Pluto, Roman god of the underworld, because it's a cold, dark place. So her grandfather, who was the head of that library at Oxford, went to the astronomy department, and they cabled the suggestion to the Lowell Observatory. And she was credited with the name. Now, what's interesting is that in discussion, apparently some astronomers at Lowell also talked about, they mentioned Pluto as a possibility because they want to go with that same Roman, the other planets are named for Roman gods mostly. Constance Lowell, the one with the will, who wanted a, you know, who contested it, she first suggested calling it Constance. Then she wanted to call it Lowell. They didn't listen to her, and they decided to name it Pluto. And when the announcement was made, Venetia's grandfather gave her £5 as a reward. And she was known, you know, throughout her life as the woman who discovered, the little girl who discovered Pluto. She was at the launch of New Horizons in 2006. Unfortunately, she did not live to see the flyby. She died at 90 in 2009. And the Lowell Observatory, notice they decided the name, not the IAU. They liked the name Pluto for several reasons. They said PL, Percival Lowell. They liked the first two letters. And then you've got that Pickering guy who wanted thought there might be 7 planets there. And he's like, well, PL, Pickering Lowell, you know, because he was part of the search. So it was named Pluto. Not yet. So one of the things that's important to consider is that Pluto was discovered really in the depths of the Great Depression. And that it was the good news in the midst of all this bleak, discouraging time, and really there wasn't much good news. And that made Pluto a big hit. Pluto, the discovery just excited people all over the world, and Walt Disney renamed his dog Rover after the planet, Pluto the pup. So it really was good news at a time, and it excited people. It also sort of supported the idea that, you know, anybody can accomplish something if they work hard. And Clyde Tombaugh did get a scholarship, a full scholarship to New Mexico State University, where he studied astronomy and got a bachelor's degree and a master's degree. An interesting story, when he first signed up for Astronomy 101, the instructor didn't want to take him in the class. He was like, well, how am I going to have my other students here with somebody who discovered a planet? But he was always known as a very approachable, nice, humble, kind person. Everybody, I unfortunately did not meet him. I met his son and daughter, but, you know, I wish I had, because he really was very, you know, didn't have any superior attitude. He was very, approachable. Next slide. Now, between 1930 and 1978, there really wasn't much known about Pluto. Scientists recognized it's not a gas giant because they couldn't resolve it into a disk. A book I have from about 1968, a textbook, says that it estimated it to be Earth size. They really didn't know much about it. In the 70s, astronomers started suspecting it had an atmosphere from doing spectroscopy and seeing methane there. But the next breakthrough was in 1978. And what this is an image that was taken of Pluto, but it was put under a microscope. An astronomer named James Christie and a colleague, Robert Harrington, were looking carefully at these images of Pluto because they wanted to determine how big is it, what exactly is its size. And he put the image under a microscope. It did not look this big, and he noticed there's a strange bulge that seems to rotate with Pluto. And he looked back at older images, put them under the microscope, and found that it rotated at the exact period of Pluto's rotation period, which is like 6.4 days. And from that, he realized Pluto is a moon. This was thought to be a defective plate because of the bulge. Turned out, no, it shows that Pluto has a moon. And that really was a turning point, because by it having a moon, that enabled a lot more, that helped astronomers figure out a lot more about it. Charon, Pluto's moon, it can be Charon or Charon, that both names are acceptable. James Christie wanted to name it after his wife. Now, you can't really do that. You have to use mythological names, because otherwise people are going to name things after politicians, and they didn't want that. But his wife's name is Charlene. But then they found, oh, Charon was the ferryman of the underworld, and that fits with the mythology. So those people in the know pronounce it Charon, like his wife Charlene, and people who are more into mythology pronounce it Charon, but it's really the same name. And what's interesting is Charon is half the size of Pluto. And it's only, the separation between them is only 12,000 miles. So they're very close together. So one of the reasons Pluto was thought to be so much bigger than it is for all these years is that people didn't realize that they were looking at two objects, not one, and they were too close together to separate. Okay, and yeah, once they found out, Pluto had a moon, they were better able to constrain Pluto's size. The next discovery, next slide, was in, wait, did you skip the Neptune one? Hold on. Okay, so the 80s were important. Neptune, again, just like it led to the discovery of Pluto, Voyager 2 flew by Neptune in 1989. That was the beginning of the New Horizons mission, because at that point, Alan Stern and a group of young scientists, that I think they called themselves the Plutophiles, as in, lovers of Pluto, they decided we need a mission to Pluto. Voyager 2 went to the 4 gas giants. Voyager 1, there had been some thought of sending it to Pluto because it went to Jupiter and Saturn. Didn't go to the Uranus and Neptune. But then scientists decided it was either Pluto or Titan, Saturn's moon, and they decided to use it to explore Titan. They couldn't go to Pluto. So the idea and the planning for New Horizons started when the Neptune flyby. And that happened, and that's the image of Neptune. The only images we have are from that flyby, except for telescopic images. What happened? I'm sorry. Oh, no. Did you have a question? Okay. What happened? But another thing happened just a little bit before that in the 80s, and that's the discovery of that Pluto has an atmosphere. Scientists already, there was some question as to whether it had one because of what the spectroscopy was showing. And once Charon was discovered, they were able to determine that Pluto and Charon would occult each other. They have this series of occultations that happen only once every 124 years. And Pluto was also going to occult a star on several occasions. And when that happens, you can learn a lot about the object that's doing the occulting. Because when Pluto passes in front of the star, if the light immediately goes out, then it means Pluto does not have an atmosphere. But if the light of the star dims, slowly goes out, and then comes back, that means there is an atmosphere because of refraction. And so a group of astronomers got an airborne astronomy, the Kuiper Airborne Observatory. They actually were observing Pluto occulting a star from a plane, and they found out Pluto has an atmosphere because So that really was a huge discovery. Next. Okay, now the Hubble Space Telescope, probably everybody knows, was launched in 1990, and astronomers had wanted a telescope. The idea of a telescope in space was a big deal because you could see things without light pollution, without atmospheric distortions. It would be a whole new set of eyes. And when it was launched, the mirror had some errors, so it took about 2 or 2.5 years to fix it. But once Hubble was launched, our views of Pluto got better. Wait, this is before the other one, right? This?
Sorry.
Okay, no, yeah, this. Okay, so this is the first image Hubble took of Pluto. This pixelated thing in 1994. This is the best it could get. Doesn't really tell you that much. Then there's the next one. They separated, okay, this is like 1996, Pluto and Charon. Hubble was able to separate them into 2 worlds. So now you see they're close together. This is the 2 of them. You see they're both round, they're disks. Charon is large enough to be round. And Hubble then later was used basically conducted more observations and was used to discover that Pluto actually had 4 more moons. In 2005, Hubble discovered 2 small moons called Nix and Hydra, and the New Horizons mission was already close to launch. And the names Nix and Hydra are from mythology, but there's a little catch with that because the NH was equated with New Horizons. New Horizons, so the whole idea of having a mission to Pluto, this group of people was pushing it, the scientists were pushing it for 25 years. They got it on the decadal survey, which is NASA's list of what are top planetary science priorities for the next decade. But it was canceled. The funding was canceled 5 times. Finally, it was approved in 2001, and it launched in January 19th, 2006. And that really, that's a whole new chapter about Pluto, because most of what we know now is from New Horizons. New Horizons revealed Pluto from those pixelated images and this to real worlds. Next slide. So NASA, okay, and this is okay. So we have 2 moons found in 2005. New Horizons launched in 2006. The team said, okay, we're going to observe the 2 little moons too. Well, 2 more moons were found with Hubble. While Hubble was being used to make sure that that New Horizons took a path where it wouldn't hit any rubble or tiny ring particles. They thought maybe they're rings or more tiny moons. But instead, Hubble discovered 2 more moons, one in 2011 and one in 2012. And those are Styx and Kerberos. So on the bottom there, you've got the orbits of all of these. You see Pluto and Charon in the center, and then you've got the other 4 moons. And up on the top, that's a comparison of Earth's moon, and then Eris, which is another Pluto-like, a small planet discovered in 2005. There's Pluto and there's Charon. Those are the Pluto and Charon are New Horizons images. And what's interesting about New Horizons is it was the first of NASA's New Frontiers mission, which is an intermediate class in terms of expense, under $1 billion, led by a principal investigator. So New Horizons cost $700 million. There were various versions proposed, canceled. It was given the highest priority in NASA's 2003 to 2013 decadal survey. And on January 19, 2006, it was launched on an Atlas V rocket. It was this grand piano-sized probe, very small, launched on the biggest rocket they had, with 5 solid rocket boosters and a 3rd stage, making it the fastest spacecraft ever to leave Earth. It was going at 36,000 miles per hour, past the moon in 9 hours, as opposed to Apollo took 3 days. And within 13 months, it was at Jupiter. And there they were going to observe Jupiter and its moons, test all the science instruments, and then use a gravity assist to speed it up to Pluto. Even with that gravity assist, the trip took 9.5 years. I'm sorry. Okay, next slide. So now, Clyde Tombaugh died in 1997. He already knew that there were plans for a mission to Pluto, and he had an agreement with the scientists who were planning it to put some of his ashes on the spacecraft. So that's that little container there, so that he could actually go to Pluto. So now some of the anticipation in terms of what would New Horizons find. When Voyager 2 imaged Neptune, it also imaged its big moon Triton. And Triton rotates in the opposite direction that Neptune does. So it's known to be a captured Kuiper Belt object. And the Kuiper Belt hadn't really been discovered at that time. It was a theory. It was probably an object, a planet in its own right that Neptune captured. And it's apparently going eventually in like a couple million years to crash into Neptune. But many people expected Triton and Pluto to be similar, because Pluto's kind of at the edge of the Kuiper Belt, which is this big belt of mostly tiny rocks and ice particles, but a few planet-sized objects. So yeah, there was this expectation maybe it's going to be similar about Triton. And next slide. Okay, so here's the New Horizons spacecraft, if you can see it, and it has 7 science instruments on it. The New Horizons team, when they do presentations, they would bring models all the time. And it had the Long-Range Reconnaissance Imager, or LORI, is a long focal-length imager for high-resolution images at visible wavelengths. It's a telescope with an 8.2-inch aperture, and its goal is to study geology of Pluto and its moons. It also helped refine the trajectory on the way to Pluto. The Ralph telescope has 3 black and white imagers and 4 color imagers, and it's the main eyes of New Horizons. It had 2 parts, the multispectral visible imaging camera, or MVIC, and the linear etalon imaging spectral array, or LISA. And it studied the geology and obtained surface composition and temperature maps. Now that was Ralph. Then you have Alice. You see Alice and Ralph. Yes, that was in reference to the honeymooners. Alice is a sensitive ultraviolet imaging spectrometer that studied the composition and structure of the atmosphere. REX is a radio science experiment to measure atmospheric pressure and temperature. SWAP measured the solar wind at Pluto and the interaction of Pluto with the solar wind. PEPSI is the Pluto Energetic Particle Spectrometer Science Investigator, and its goal was searching for atoms escaping Pluto's atmosphere. And the Venetia Burney Student Dust Counter, yes, named after Venetia Burney, was built by students. It was the first science instrument built by students launched on a NASA mission, and it measured dust particles in the outer solar system. New Horizons made its closest approach to Pluto at 7:49 a.m. Eastern Time on July 14th, 2015. And that closest approach was it flew within 7,750 miles of Pluto, or 12,500 kilometers. And there was a big celebration at it's JHU APL, Johns Hopkins University Applied Physics Lab, where the mission's based, in Laurel, Maryland. It's kind of funny because my name is Laurel, and I was there, and they did a big countdown, you know, just like New Year's Eve, and it was very celebratory. Now the way New Horizons, it's limited. It has limited fuel, and it couldn't both communicate with Earth and image Pluto at the same time. So for about 22 hours during the closest approach, it was out of touch with Earth and just taking all the instruments were taking as many images as possible. So there was this anxiety that what if, you know, it takes 9.5 hours, I think it was like 4.5 hours each or more each way at the speed of light to get messages from here to Pluto, then back from Pluto to here. And there was some anxiety, like what if it's hit by like a pebble or a dust particle? That could destroy the spacecraft. So until about like maybe close to 9 o'clock that evening, there was some worry. But then when around 8:52 p.m., the mission, they heard back from New Horizons, and then you had all the cheering and applause and everybody's in an auditorium. That means it made it through without any incident. Now, okay, next slide. Okay, so here's some basic information that we knew about Pluto. I think that diameter is slightly wrong because Pluto ended up being a little bigger than they thought. It's 2,370 kilometers in diameter, or 1,473 miles in diameter. as far as its orbital period, so its perihelion, or closest point to the sun, is 29.7 astronomical units. 1 astronomical unit is the distance between the Earth and the sun, which is about 93 million miles. So, but its aphelion, or furthest point, is 49.9 astronomical units, which is a really big difference. And one of the reasons there was such an urgency to get that mission in is because Pluto was at its closest to the sun in 1989, and then it started pulling away. And Pluto now has an atmosphere, and it was thought that this atmosphere might freeze onto the surface when Pluto gets further from the sun and gets colder. So, you know, the group, the New Horizons scientists wanted to study the atmosphere. You know, they wanted to get there before the atmosphere freezes out. It was already past perihelion, but then they did see the atmosphere. So this is some of the information that was known about Pluto. Okay, hold on. All right, next slide. Okay, so here, this is a composite. These images were taken on approach from June 25th to July 14th, 2015, and you see how, you know, it got bigger in the frame. Pluto got bigger in the frame, and that was the July 14th, the flyby date. And one of the things that was done is before New Horizons, you know, went out of contact for the flyby, it sent back an image of Pluto with that heart shape, which got a lot of attention and a lot of love. And just in case the spacecraft was destroyed, they'd have that image. So this is Pluto getting closer, and yeah, that scientist there was like a lot of attention on that heart-shaped feature. It's very prominent. New Horizons found some very interesting information about Pluto, and mainly what was expected was it's this dead rock with lots of craters. Well, that is exactly what it was not. It's alive. Pluto is very geologically active. Its surface interacts with its atmosphere. It has cryovolcanoes. It's more active than Mars, which surprised a lot of people. Next slide. So that image, that last image that was sent back with the heart, of course, was used. You know, that appeared all over in memes. This was because over 9.5 years, everyone was like, "Are we there yet? Are we there yet?" So that's we are there, and that image was shown at the JHU APL on the day of the flyby, saying this, you know, we got this. This is the best image. And the next day, this image was without the Happy Pluto Day we are there, was all over newspapers, front pages in 7 continents, including Antarctica. It was a huge hit that kind of almost parallels the announcement back in 1930. Okay, next slide. This was enhanced by a friend of mine named Andrew Brown. You've got Triton on the left and Pluto on the right. Triton is Neptune's biggest moon. And so he's, you know, again, we're seeing the southern portion of Triton, the northern hemisphere of Pluto. That's a Voyager 2 image. Some of the terrains are similar, some of them are different. It's not as Triton-like as expected. Next slide. Okay, so here again, Andrew Brown enhanced this. High-resolution images of both Triton on the left and Pluto on the right. So there you see some very similar. See how the terrain looks very similar, the kind of modeled. Yeah, there are some similarities. Next. Okay, so now the heart-shaped region on Pluto was named Tombaugh Regio after Clyde Tombaugh. The left side of that is known as Sputnik Planitia. It was originally Sputnik Planum, but then they changed it to Planitia because of the geology was slightly different than they thought it was. This is a cutout map of Sputnik Planitia, which has no craters. It's a floating glacier, about 1,000 miles wide, mostly of nitrogen. And you see all those little shapes. They're called those polygonal shapes. It's segmented terrain. They're not sure what's going on there. They think there's convection going on in the mantle, which is, you know, Pluto is layered like Earth into hot material is rising up and cooler material is sinking down. And so you've got all these this little polygonal thing here, you know, those terrains there, and then you've got these lines in between them. They're not exactly sure. They know it means it's active. There's geology happening. Any crater, any from an impact has been erased. But there are still a lot of questions about it. Next slide. Okay, these are called extensional faults, and they found, if you see those lines, those are like a fault you'd have on Earth. Again, that indicates Pluto has tectonic activity. It's, there's something going on beneath the surface, and it's believed that Pluto has an internal heat source. Now, unlike Triton, it doesn't orbit a giant planet, so it's not tidal forces. The internal heat source would probably be radioactive decay of rock. Next slide. Okay, so this is Charon on July 12th, 2015. The big moon. And notice right on top, that big dark spot, that's the north pole of Charon. And you also see that crater on the lower left, and it's enhanced over there. It's got this big crater. Charon has more craters than Pluto has. Pluto has incredible diversity in terms of colors of its surface and the types of terrain. Charon has less diversity. It's kind of like a grayish color, except for that north pole that's a reddish. Pluto has many different colors, mostly reddish, brown, and then the whiter reflective Sputnik planum, and even the other part of the heart region. All right, next. Okay, so this is Charon, again, New Horizons, and Andrew Brown enhanced that. If you look sort of toward a little bit below the center, there's a huge fracture going across the moon. And that's believed to have, Charon is believed to have once been geologically active, and to have once had a subsurface ocean that subsequently froze, and the freezing broke apart the surface and let this canyon is bigger than the Grand Canyon. It's huge. The top of, which is that, here it's black and white, but that reddish North Pole is believed to be atmospheric particles that came from Pluto, that escaped from Pluto and settled on Charon. Remember, they're very close together. Next slide. Okay, so this is Pluto panoramic image of Pluto backlit as New Horizons was flying away. And what you have here is you can see that there are layered hazes. They knew Pluto has an atmosphere, but no one expected it to be this incredibly complex. There are multiple layers, and they even were able to use this haze to see some features on the dark side and make out some mountains there. Next. Okay, so here you have a cutout of that little region beneath the heart. And the names are very interesting. They were done through a public campaign in conjunction with the IAU, and some of them are after space missions, and some of them are after fictional characters and missions. That area, that dark area that was sometimes called the whale, over there where that thing is, if you look at the whole area, it looks a little bit shaped like a whale, is called Cthulhu Regio, if people are familiar with the Cthulhu mythos. And that area is very dark. It has mountains in it. And again, the dark areas are believed to be covered in what are called tholins. There are these hydrocarbons that they're the result of hydrocarbons in the atmosphere reacting with sunlight. There's also methane snow. If you see that middle, the other ones I think in ultraviolet, but you see the methane snow. That's snow. It snows on Pluto. You can go skiing. Okay, this is all right. Next slide. Okay, so Pluto has flowing, especially Sputnik planum, and even other part of the other part of the heart, not as much, but to some extent, has flowing ices on it. They're similar in some ways to the glaciers that flow on Earth. Here, the arrows were obviously drawn in, but the swirl shapes show that there's this surface layer, and they're flowing around these like rocks and obstacles and then into lower levels like depressions. It seems to be a lot like glaciers on Earth. So that's a very smooth terrain there, and you see borders of a rougher terrain. Which again, this is the bright area. So this is, here it still says Planum because that was the initial name for Sputnik. Next, okay, so here, these maps were assembled from LISA, the LISA instrument, and basically it's from images taken in different spectra, and what it shows is concentrations of different elements. This is Pluto. So you see on top, the purple, that's methane. Nitrogen is the second one on top, and then you have carbon monoxide and water, the fourth one, where these things are concentrated. Pluto has a lot of water, and it's got very, very tall mountains that are made of water ice. The geologists know this because it's the only material that would remain, that would be this hard and be able to get that big, that far, and that's such cold temperatures. Its average temperature is minus 380 Fahrenheit. So I like to say bring a jacket. Next slide. Okay, so this is that North Pole area again. And it was named Mordor Macula, if you know Lord of the Rings. Again, Pluto is, Charon is not as diverse in color, but that North Polar area is very interesting because that material is believed to have come off from Pluto's atmosphere. Next. Okay, this area that's cut out is called, it's just below the heart, it's called Crun Macula. And you've got rugged highlands, again, you've got the cutout there, cratered uplands, blocky mountains. Look at how blocky it is. You've got bordering that smooth terrain on Sputnik Planitia. It's a really sharp difference. There are two mountains south of Pluto's heart named Wright Mons and Picard Mons, yes, after the captain, that are believed to be cryovolcanoes. And they're ice volcanoes instead of lava volcanoes. And they have that top being pushed in, top of the mountain pushed in like a volcano would. This was a complete surprise too. Next. Okay, so this is the bladed terrain. This is in the region of Pluto called Tartarus Dorsa. Tartarus is a region of the underworld. So you've got this very bladed area that's kind of, it's these sharp ridges. Again, they're not fully sure how these formed, but it certainly was not expected. Next, okay, you've got pitted terrains on Pluto. Here again, you see the differences in the surface. There's a whole area, and I have a bigger picture of this later, of pits. These pits are up to 25 miles long, up to 2 miles deep, but they're not craters. They don't really know what causes them. Next. Okay, so this is, again, Andrew Brown helped enhance this. This is what New Horizons image on approach, and on departure, it almost looks like a solar eclipse, where Pluto is backlit from the sun. And this, in other pictures, you can see that atmosphere is blue. The sky on Pluto is blue. And it's not completely dark either. It's at noon, it would be around kind of like twilight here. Next. Okay, there's another view of Pluto's layered hazes. You see how through the hazes they were able to make out some areas in that darker area, right at the terminator. Next. Okay, yeah, this is a bigger picture again of the departure image with that blue haze. And that's the scattering of light from the atmosphere. This is a composite combining images in blue, red, and near infrared. This is as close, this was made to look like what the human eye would see if you're on that spacecraft departing from Pluto. It was made to be as close as possible to what we would see. Next. Okay, so here you've got cracks on Pluto's surface, west of Sputnik Planitia. If you see that in, like on, there's a crater there, and you see these huge cracks. Again, that they're not sure how those got there, but they indicate geological activity. Pluto is believed, based on a lot of these features, to have a possible subsurface ocean. And that is, what that does is basically change the whole concept of the habitable zone. If you heard of the habitable zone, it's believed to be where can life as we know it exist, in a world where liquid water can exist on the surface. Now, in our solar system, it turns out Earth is the only world that has its water on the surface. But there are a lot of other worlds that have water beneath their surface. Europa, Jupiter's moon, Enceladus, Saturn's moon. I think Ganymede and Callisto, Jupiter's other moons, are also thought to have an ocean. Titan has methane lakes. Now Pluto, Ceres, and also Pluto are believed, they don't have definitive proof, but there's evidence that there's a subsurface ocean. What that means is there could be microbial life there, because microbial life was found in very deep on Earth's ocean where there's no sunlight, in hydrothermal vents. So this is why we're sending the Europa Clipper mission to Europa, and it suggests the habitable zone may be a lot further than anybody thought. This is, okay, next. Okay, yeah, this is a composite image of Pluto and Charon with the color. Now these, and it combines blue, red, and infrared images taken with Ralph and Emvik. Now what's interesting is that Pluto and Charon are tidally locked. They show the same faces to each other, and that's accurate. The side, New Horizons flew so fast that unfortunately it could only image one side of Pluto in high resolution. The other side it only got in low resolution, because with a 6.4 day rotation period, New Horizons didn't have the opportunity. It couldn't break or it couldn't go into orbit. So there's one whole side of Pluto that we see in much less detail. That's the side facing Charon. The side with the heart here, this is the one facing away from Charon. On this side, you would never see Charon in the sky. On the other side, it would just hang there motionless all the time. So it's a composite that shows the two of them. As you know, as they would, it may not be to scale in terms of the distance, but in terms of, you know, the features and about the difference in their. Charon's about 50% the size of Pluto. Okay, yeah, next. Okay, okay, this is, again, surface variation, flowing ices. If you see this here, again, they put in the arrows. You've got Sputnik Planum or Planitia on the top. You've got the two mountain ranges, the Hillary Montez and the Norgay Montez. The Hillary Montez are not named after the presidential candidate. They're named after Edmund Hillary, the explorer. And you see this, you see Cthulhu Regio, the dark region. You see mountains there, an infilled crater, the polygons, Sputnik Planum. Look at this diversity of terrain. I mean, you don't see this even on Mars. Okay, next slide. The bigger image of the pitted terrain. So here you can actually see those little dots that are pits on that right side, and they don't know what those pits, and then the much more rugged terrain over there. They don't know what causes the pits. So one thing that was really interesting is, okay, Pluto, this is a quote from Science magazine in October 2015. Now it took a year and a half to get all the data back from New Horizons. But 3 months into the return of the data, Science magazine wrote, Pluto displays a surprisingly wide variety of geological landforms, including those resulting from glaciological and surface atmosphere interactions, as well as impact, tectonics, possible cryovolcanic, and mass wasting processes. The mountains with the volcanoes, I forgot to mention, are about 4 miles high. So they're on the south of Pluto's heart. Next. Okay, so this is now the small moons. New Horizons got less images, more about the two discovered in 2005, Nix and Hydra, a little bit less about the Styx and Kerberos. But here what you have is an image taken on approach in April 2015. The one on the right is exactly how it looked, and they had to process it to take out the glare of Pluto, and then of course put in, they could see the moons and the orbits there. So this is on approach. You see how it's basically known as the Pluto system. Next. Okay, so this is a composite that shows them comparison in size. Charon is big on the bottom there. Kerberos is very dark. The others are very bright. And there's some interesting issues that things they were able to learn. One is that the surface craters on these 4 small moons show that they're all the same age. And it's believed that they were all created in the same impact that formed Charon. You know the giant impact theory of Earth's moon, that a Mars-sized object hit proto-Earth, and eventually that's how the moon formed. Well, the same thing happened at Pluto. That's how Charon was created, and it's believed it created all of these small moons as well. These moons are interesting because they have very chaotic orbits around Pluto, and they don't orbit Pluto itself. They orbit what's called the barycenter, or center of gravity, between Pluto and Charon. Many astronomers consider Pluto-Charon to be a binary or a double planet system, because the center of instead of Charon orbiting Pluto, the two objects orbit a center of gravity that's closer to Pluto, but that's outside of Pluto. So many consider it to be the only binary planet system that we know. We know many binary star systems. And the four moons orbit the binary. They orbit the barycenter, not Pluto itself. Next slide. So the orbits are not very well understood at all. Hydra rotates 88.9 times to make in one orbit around Pluto and Charon. Some of these moons tumble to the point that if you're standing on it, you might see the sun rise in the west and then set in the north. There's no rhyme or reason. Okay, Hydra rotates very fast. Nix spins backwards. They all appear to be covered with water ice, although Kerberos is darker. And Mark Showalter, who's a co-investigator on the New Horizons mission, said there's clearly something fundamental about the dynamics of the system that we do not understand. Why they orbit this way is New Horizons raised more questions than answers, and why they orbit this way is one of the mysteries. Next slide. Okay, so you have again another meme created, and there are so many of these. This heart is one of the reasons Pluto just won over people's hearts. And this is Dear Earth, thanks for visiting. Next. Okay, so Alan Stern, who's the principal investigator of the mission, and basically has pushed for it from the beginning, lists what he sees as the top 10 New Horizons discoveries. The first one is the complexity of Pluto and its satellites. The complexity of Pluto and its satellites is far beyond what planetary scientists expected. 2, the degree of current activity on Pluto's surface and the youth of some surfaces on the dwarf planet are astounding. 3, Pluto's atmospheric hazes and lower than predicted atmospheric escape rate upended all of the pre-flyby models. Pluto's atmosphere was believed to be either freezing out onto the surface because it's receding from the sun, or escaping because of interaction with solar wind. But the escape rate of the atmosphere is much, much lower than they thought. And it's now, no one knows for sure, but believed possible that Pluto may retain its atmosphere throughout the entirety of its orbit. We won't know because it's only been 87 years and Pluto takes 248 years to complete one orbit. 4, Pluto's atmosphere is blue. 5, Pluto's heart-shaped nitrogen glacier, actually it's that one side of it known as Sputnik Planitia, is the largest known glacier in the solar system. 6, Pluto shows evidence of vast changes in atmospheric pressure and possibly past presence of running or standing liquid volatiles on its surface, something only seen elsewhere on Earth, Mars, and Saturn's moon Titan, which is sometimes seen as an early, Titan is seen as an early analog of early Earth. So yeah, there could have been liquid water flowing on its surface. Next, 7, Charon's dark red polar cap is unprecedented in the solar system and may be the result of atmospheric gases that escaped Pluto and then accreted on Charon's surface. 8, Charon's enormous equatorial extensional tectonic belt, that big gash there, hints at the freezing of a former water ice ocean inside Charon in the distant past. Other evidence found by New Horizons indicates Pluto could well have an internal water ice ocean today. 9, all of Pluto's moons can be age dated by surface craters to have the same ancient age, about 4 billion years, adding to the weight that they were formed together in a single collision between Pluto and another planet in the Kuiper Belt long ago. And 10, the lack of additional Pluto satellites beyond what was discovered before New Horizons was unexpected. They really expected more moons, possibly rings, and they didn't find any. Okay, and so now, this is an image I took at the flyby. That is Annette and Alden Tombaugh. Those are Clyde Tombaugh's daughter and son, and the families were there. And if you see up there, it's kind of blurry, but that was a countdown, and it says 0 days. That was right at the the early morning flyby, and they got up there to speak. And they got they're not scientists, but they got very involved when in 2006, when the controversial vote of the IAU happened to reclassify Pluto. Next. Okay, so I did want to say something about the controversy of Pluto. So planetary science is really a relatively new field. It's kind of splitting off from astronomy. Because we only have really learned about planets up close in the last 60 years during the space age. So, many people don't realize it's coming into its own as a separate field. It's sort of geology, but it's not geo means Earth, planetology. Now, there are two ways of looking at the solar system, and this is about the controversy. They're called dynamics versus geophysics. So here we have now, dynamics, I'll explain this first, focuses on what an object does to other objects, and says, in order for an object to be a planet, it's got to be the big guy on the block. It's got to be the biggest thing, and it sweeps everything else out of its orbit or captures it as a moon. Geophysicists say, oh, no, it doesn't matter what the object does to other objects. It's its intrinsic properties that matter. And if it's big enough and massive enough to be rounded by its gravity, then it's a planet. And here you have these are papers that went into that were referenced during the IAU meeting, but weren't used exactly the way they were intended. Alan Stern and Hal Levison created this distinction here. They used a mathematical formula to distinguish two types of planets. Uber planets were those in orbit around a star that are dynamically important enough to have cleared their neighborhood, and then underplanets were the ones that are not able to do so. And they actually determined a mathematical parameter for gravitational dominance and ability to clear an orbit. Next. Okay, so this is planet classification 1, where they distinguished uber and underplanets. However, they said they did say underplanets are also planets. They're just some planets dominate their orbits and some don't. Next. Stephen Soter came up with a different method, again mathematical, where he went by mass and said that a planet has to have a certain aggregate mass, and if that mass is over 99% of the total mass in its orbital neighborhood, it's gravitationally dominant, and then it's a planet. And then he had and if you look at the next slide compares the two side by side, these two classification methods, and it may be hard to see here, but the dividing line is almost the same. Mars and Mercury. Mars is exactly on the dividing line of what's gravitationally dominant. Pluto's series are below it. They're two different systems, but no one ever said, and Soter used the term dwarf planets, but he didn't ever, the assumption was dwarf planets are just smaller planets that are not gravitationally dominant. Next. Okay, now in 2006, this was a very political and controversial decision. I personally oppose it. I think it's wrong. And the debate, like I said, didn't start now. It started in 1930, not 2006. But what the IAU did was take those two papers and come up with this definition that a planet has to be in orbit around the sun, not a star. The sun has sufficient mass for its gravity. It has to be shaped by its own gravity. That's hydrostatic equilibrium, rounded by its gravity, which is an important threshold because that's when an object becomes really complex and starts developing planetary processes and has cleared the neighborhood of its orbit. But what happened was this resolution was done on the last day of a 2-week conference. It was thrown together at the night before, didn't go through the regular process of being vetted by the committee, and the vote, and 333 to 91 voted that dwarf planets or underplanets are not planets at all, but another class of objects entirely. And that's really what the crux of the debate is. That's where the dissent comes from. Alan Stern coined the term dwarf planet all the way back in 1991, but the intention was dwarf planets are planets, not something else. So that really was the controversy. That's really where what the crux of the controversy is. Next. So now you have, this is 2017. Kirby Runyon, who was on the New Horizons mission, just getting his PhD, proposed a geophysical definition where he's saying a planet is a substellar mass that has never undergone nuclear fusion and that has enough gravitation to be round due to hydrostatic equilibrium regardless of its orbital parameters. Now, there are other issues with the IAU, because if you say a planet is to orbit the sun, then the 3,000 something exoplanets we found are not planets. There are also rogue planets that don't orbit any star. They just free float in space, and those wouldn't be planets. Kirby Runyon came up with this definition, but did not present it to the IAU. He presented it at the Lunar and Planetary Sciences Conference in March. There have been requests to the IAU to reopen the issue, and they have refused to the point where it's getting to be like they don't want to reopen it. So the question is, who decides? Is it only the IAU, or can it be decided by a different group? The media really did a disservice because they portrayed, oh, Pluto's not a planet anymore because the IAU decided. When what they should have said is, you know, there's this one group that said it's not a planet, but then you've had the same number of people signed a petition immediately rejecting it. So really it's an ongoing debate. And I like to say it's not a true or false question. You know, is Pluto a planet? It's not true or false, it's an essay question. Next. New Horizons next slide. New Horizons raised so many questions that immediately the group of scientists on it were like, we need to go back. And the idea is go back with an orbiter, possibly have a lander on Pluto and or Charon. This is an artist's rendition of a lander on Charon looking at Pluto. That's on the Pluto-facing side. And there was a meeting in late April of about 35 scientists talking about how do we get this into the next decadal survey. They want to go back to Pluto. Some want to go visit other Kuiper Belt objects. An orbiter and a lander are possible with today's technology. NASA is developing this space launch system. It's like a huge rocket. They could use that, the SLS, to launch. And Alan Stern said they would have to travel really fast and then brake to go into orbit. But New Horizons raised this whole set of questions, and now they're looking for answers. As much as it gave us most of what we know about Pluto, it raised a lot more questions. So I just wanted to show, and with showing some of how Pluto inspired art. You saw some of them. This is a Pluto Valentine. Again, people creating these memes. There's a winter holiday card. There are birthday cards. People have created these online. Next one. Okay, this was created by a friend of mine, Mike Raffel, who's also a very strong Pluto supporter. And that's Pluto in the heart with all these different colors. Next. Oh, okay. Oh, wait, was there another? No, okay. Now, this is a YouTube. I want to end with this video. And what this video is images taken from New Horizons to simulate what landing on Pluto would look like. And, of course, it only goes as far as New Horizons went to the planet because it didn't go, we don't have anything closer than that. So, now, basically, this was put together with lots of New Horizons images, and I thought it was really, sometimes it's the picture or the movie that's worth 1,000 words, and Chris wanted to add some music to it, so that's it didn't have music, and I was going to say, well, that's NASA, they didn't put music. I'm not technical, I know how to do that, so, but yeah, I wanted to show this because I think it really, it does a good job simulating what landing would look like. And this is why I asked about internet access. Sorry, yeah. No, he really worked hard on it. I barely know. I don't remember. I've done PowerPoint presentations, but it's been a long time. So he really, if anybody needs a PowerPoint, I mean, Chris is great with this. It's not my my strength really, but enormous amount of work and wanted to do the music. If we can't get the music, I'll just do the, okay. Yeah, but this was created by NASA, and most, of course, all the images of Pluto are NASA images. All the, the New Horizons images, and they are free for the public to use, and they want people to learn about what, about the mission and what it's taught us. So it's actually a YouTube. And that's the going away, receding. Oh yeah, Pluto, the mission has been extended. It is now going to a Kuiper Belt object, MU-69, that is not big enough to be round. And it will get there on January 1st, 2019. And what's interesting, for those who say Pluto can't, the orbit clearing issue, they had a look with Hubble multiple times to find an object within that New Horizons could reach. So it's not like when you think of Luke Skywalker in the field of asteroids, and he's dodging, all the asteroids. There's this, this whole area. If they have to look so hard to just find another object, that, close enough to take a few years, what does that tell you about orbit clearing? Pluto's orbit ranges from 29 to 49 astronomical units. If Earth were in that orbit, it wouldn't clear all the tiny Kuiper Belt objects either. And I can't not say the Star Trek test. Alan Stern likes to say that he believes in using the Star Trek test for determining if something's a planet. And basically, it goes like this: if Kirk and Spock are on the Enterprise and they're looking out of the bridge, they see this big round thing there. It's a planet. No need to calculate whether it's on. So these are all the people I want to thank, including Ed Murray and Chris, who are in the room, and Amateur Astronomers Incorporated. Of course, I have Alan Stern there. My friend Steve Collier couldn't make it. Kirby Runyon. Andrew Brown does great processing. He's in England, actually. So yeah, I don't believe when people say it's only Americans that want that support Pluto being a planet. That's not true. That's a false argument. But if anybody has any questions, I'd be happy to answer. Yeah?
It's not really a question. I'm almost embarrassed to ask. No, I was very upset when Pluto was dethroned as a planet. And I have a 2-minute animation, stop animation, all hand drawn, about what Pluto did. I want people to see it's on YouTube.
Oh,
If you want to.
Do you know how to find it?
Well, yeah, it's called Pluto Planet Protest. There's a lot of them like that, though. Well, my name is Raquel Solomon.
Okay, let me get in here.
I mean, it's...
Well, to tell you the truth,
Do you mind seeing it?
I mean, if we can do it technically, and he'd be
Yeah.
the one, I can't, I wouldn't. But when it happened, I was out.
Oh, Pluto Planet Protest?
And I decided to fight it. I'm trying to present both sides, but I do have a position. And, I think the media did a huge disservice by acting like the IAU view is the truth. It's not
That's
gospel
not that
truth.
one. You see, other people have the same name. But if you put Raquel, R-A-Q-U-E-L, that's my name. Solomon, it might come up. Maybe Welsh will come up.
Solomon.
S-O-L-O?
Solomon. It's looks like an animation.
Pluto is a planet?
Look. Yeah, Raquel Solomon's at the top.
It's
I
Top
saw
one?
her name, Yeah.
Pluto planet practice.
Yeah, it's just like 2 minutes. A minute and a half.
I think a lot of people understood,
There it is. Hope you look. It has music too, but you can't hear it.
Oh,
So
no,
I
it
made a
wasn't,
mistake
it's
about
the
NASA.
IAU, it's not,
Yeah,
NASA's
I
innocent.
apologize.
It's
I
okay.
apologize. I'll switch it.
Pluto is crying.
Yeah. Well, you see, it's a planet if it has emotions.
Only reason why I was sitting, she was dead.
Yes.
Okay, thanks a lot. for
Thank
reminding
you.
me.
Yeah, but, you know,
Showing up in NASA.
very nice.
Yeah, you can change it, yeah, because people think it's not NASA.
Yeah, I
And in fact, NASA
apologize.
does not take a position.
Yeah.
Again, it's not, the media did a disservice, because science isn't decided by authority, it's the data that decides. You can't just issue a decree, and I think the media didn't question that enough. Any other questions? Yeah.
Wait, do you definitively believe in space?
More,
More out there questioning, but out of curiosity. in
well,
terms of
what
study.
exactly do you mean by that? Whether
Well,
there's
no, in
life
terms
or?
of outer space. I'm playing devil's advocate completely
Oh.
here.
Okay,
on
but
some
that's
level.
very broad question. What about,
Well, like in terms of like the solar systems as well as like not alien life, but like in terms of space itself, like outer space.
that there are other planets orbiting
Correct.
other stars?
Correct.
Oh, we already know there are. I mean, we have missions, the Kepler Space Telescope, there are multiple ones that they've found over 3,000 planets and many more planet candidates, and now they're just on the border of trying to find whether they might be habitable for life as we know it. So if that's what you meant, I mean, and there could be life on some of them. We're just at the beginning. 1992 was the first ever finding of a planet orbiting another star, and that was a dead star called a pulsar. It wasn't even a regular star. 1995 was the first planet orbiting a regular star. So that was a question, that was around for so long. Now we know that other stars do have planets, which is why it makes even less sense to say a planet is to orbit the sun, because most don't. Is that what you?
Yeah. No. It's just it's a devil's advocate question. Mainly because I can't see it, I can't touch it, I can't feel it. I mean, I can see it in the sense of the moon and the stars, perhaps.
You can see more with telescopes and
telescopically, of course, but like sensory perception wise, I can't go visit it myself. So how am I to know?
right.
It's the
And so
ancient in me,
the what?
It's the ancient in me.
Oh, okay. Yeah, I mean, I understand that because a long time ago we couldn't go there and go to these, but we can go there robotically, and I think, there's enough evidence that yes, we've gone to these worlds. It's not a conspiracy on a Hollywood stage or something. Yeah.
Thank goodness.
Did you have a question?
Yes, since we're asking philosophical questions. Why married to the idea of life and water?
You mean
Like-
why do the two go together?
Yeah.
Oh, because life
The
as
life's always spoken in terms of have you found water, but you don't necessarily need water
well,
to have life.
you're right because life as we know it needs liquid water. But now this Cassini, which is
Would that be north or not south, and what's the orientation?
Oh, I
Would
think
be
that has to do with
relative to
the
our
system.
east-west,
I
right?
think that has to do with the system that the scientists have adopted for determining, and to some extent you could do it one way or the other way, which way is north and which way is south. That has
Oh, so it's arbitrary. arbitrary. It's
Well,
not-
well, it's arbitrary. It's a sphere, but deciding which, what to use, as long as they're consistent across planets and moons, it's fine. And there's more than one. That's another issue with the IAU. As long as they're consistent.
I guess that's my question. Are they consistent between the planets?
Well, I'm assuming that any people on the mission that they'll use the same parameters for all objects they visit. So as long as if you're using one system where this way is north, then you keep using that for all the objects. I'm pretty sure New Horizons is doing that. That is something that's a more detailed question. But I know there are several competing systems. But as long as you don't mix and match them, there's like once I think it was a lander that ended up it might not have been an American lander that crashed on Mars because metric system and the American system were confused, and so
Yeah.
that they got it wrong. So as long as they use the same system, and that's more technical, and I admit I have to look that up. But it was discussed at the Pluto Science Conference. So yeah, as long as they measure, if they decided to do the other version, then that would be South Pole. But it still has magnetic poles, and
Right, if it's a sphere, it's
Yeah.
spinning, and so you'll have two poles. I just was, by the very fact that you mentioned it's a consistent system, it would seem that because the planets orbit in a disk around the sun, the orientation of their rotation is same because of physics, angular momentum kind of thing.
yeah, I would, and I would, if anybody has any more insight into this, I would definitely,
I'm just guessing here, but just like the planet Earth has a molten core made of metal that spins, I would assume that based on the direction that it's spinning would tell you what is north and what is south. I understand what they're saying. There's probably different ways of approaching it, but I would guess, and I'm only guessing here, that if a planet is different, which one rotates backwards?
Yeah, you said
just
rotate
mentioned-
backwards.
Triton,
right,
Triton.
right.
Oh no, one of the small moons
Right.
rotates the other way. But those are not even round, so they're even harder.
But they could have a core in
The
the
very
middle.
fact that you say it rotates backwards, which means
Oh well,
that
the
that
opposite
threw
way
me
that
off.
the opposite of backwards in the way according to the way Pluto rotates. It's like Neptune.
That means it's possible to rotate backwards. If it's possible to rotate backwards, then you cannot have a consistent system.
No, you could. That doesn't mean that there's not. You don't know. We're not out there.
Well,
If you're standing on the sphere at the equator facing the direction of rotation, to your left is north.
Oh, yeah.
On those small moons, they know even less because they said the sun could rise and
North.
they tumble.
North is the same for all the planets in the solar system. It's above the ecliptic, and south is below the ecliptic, with the exception of, is it Uranus or Neptune, rotates on its side.
That's Uranus that wrote.
Its
Pluto
north
is
pole is
almost-
to the side because it's tilted over that
Pluto
way.
is almost
But north
on its
is above
side,
the
too.
ecliptic and south is below.
I see.
Pluto is almost on its side too, actually. The
That's
New
standard.
Horizons
Yeah.
did not have a magnetometer. They couldn't afford it. They had a very limited budget. But again, that's one of the reasons they want to go back. Anyone else?
Is there any particular reason why you enjoy studying Pluto or find Pluto out of the rest of the solar system as well as its extensions most interesting out of all of them? Like,
Well-
what led you to have interest in it, or?
I like, I love the idea of strange new worlds. Sometimes the more remote, the better. I was fascinated with Neptune when Voyager 2 flew by it. And when the IAU decision happened, I knew in my gut this is not right. And so I did a lot of research and found, all these political motivations and personality issues. But the more I read about Pluto, the more fascinating its story became. I mean, all these interesting characters like Clyde Tombaugh and Venetia Burney, and there's something about Pluto that's very compelling. I think maybe it's Pluto being the underdog. Discovered by the farm boy in the middle of the Depression. It's got a heart on its, its surface. It's Pluto is fascinating, and many people find it very compelling. I think for a long time it was seen as the mysterious unexplored world at the edge of the solar system. And now they know that there's this Kuiper belt, and that doesn't mean Pluto's not a planet. It means there are a few other objects that are big enough to be planets there too. Some people have a problem with the idea of the solar system having too many planets. I think I like having more planets. So, some of it is, a person's personal interest, what you find fascinating. I love science fiction and fantasy. I'd love to see the Star Trek world come to be. and like I said, the more I read about it, the more fascinating it is. Anyone else? Well, thank you so much.
What about that song you were?
Oh, you know what? I don't know if we have time. I didn't.
We do have time. We've got about 9 minutes
I didn't
left.
bring the CD because I was when I went over this. It was this took long enough. There's a song. There are a lot of songs. Again, the arts are a whole. There were so many protests and responses to the IU decision in the arts. There are I'm also an actress and singer, and my birthday's in July. My birthday was right before the flyby, actually. I had my birthday party and left that night to go to Laurel, Maryland. There are many songs that have been written about Pluto. Funny, some sad. And so one of these, I think it might have been written for kids. It's called Ode to Pluto, and I found it. I ordered the CD, and I sing it every year at my birthday party. It's a backyard barbecue, in the heat and everything. I know he wanted me to sing. I didn't bring the CD because I was.
Can you sing a few lines?
You'll always be a planet to me, Pluto. You're the coolest icy mass in the galaxy. Your orbit is eccentric, and Neptune's path may intersect it. But you'll always be a planet to me. I did not write it. People think I did not write it. Thank you. Yeah. So I have a CD with the background music also. So thank you so much. I really appreciate this opportunity, and I'm glad people are interested. And like I said, I don't want to, on one hand, I don't want to impose my view. You hear my view, but I encourage everyone to decide for yourself. Don't just believe. Science is not like someone said something, so it's true. So, I think it's a planet and a fascinating one.
I have one more question. You talked about an ice volcano. What's an ice volcano?
A cryovolcano. It's a volcano that instead of spewing lava, it spews ice. Now that has to do with the convection and basically the possibility of a liquid ocean beneath Pluto. The geological activity. They think that two mountains, because they have these configurations of what's known as shield volcanoes that are seen on Earth and Mars. Except on Earth and Mars, they spew lava and they're bent in the way a volcano would be. So they didn't actually see it erupting, but it looks like it may be dormant. They may be dormant. They saw two of those. Now remember also, there's another side of Pluto, and somehow this one image didn't get included, where we see these 4 dark round spots in a row. The side that wasn't imaged, it was imaged only in low resolution. We really don't know much about that side. That's another impetus to go back, especially with an orbiter. So, yeah.
Can I ask a scientific question jumping off of yours? If there's such a thing as an ice volcano, do we have any idea what kind of temperature it needs to be at?
That's interesting.
Because,
I would think that maybe it would be warmer. Like you have that there's that heat source from the radioactive decay of rock. There has to be something, and does it spew as, slush or as, water or totally ice? I don't know.
Or even because of the pressure. Maybe it heat up.
Yeah,
Well,
that convection.
Is it liquid? Like, is it kind of similar to lava in the sense that it
I'm not sure. Does anybody?
does it get
it might be
colder?
slushy.
Does it
I'm not. It may depend. Pluto, because it has such a crazy. It's almost on its side like Uranus is believed to have seasonal. Its seasons are extremely long, but seasonal changes in in its pressure, its atmosphere. So the situation changes. We haven't observed it even for half of a full orbit. So, those. I don't know if anybody's seen it. I know that there are geysers on Enceladus, Saturn's moon, that are kind of. I think some of them are liquid, a combination of liquid and ice, and but I'm not sure how much cryovolcanoes have been observed in process as opposed to after the fact. And thank you so much. I really appreciate this.
Thank you.
Thanks for the opportunity.
Thank you, Laurel, for that
You're welcome.
demonstration on Pluto. I certainly hope we broaden your interest in this fascinating planet. I know fascinating is an overused
Oh,
word.
I have a blog.
Yes.
Yes, I have. Is there? I don't know how. Is there? Where can I write? Can I write it on something in the blog? It's
post it on the Facebook.
Laurel's
Mensa?
plutoblog.blogspot.com. I'll put it there. My blog is basically an advocacy blog against the, for Pluto's planethood, but I try to bring scientific arguments as opposed to just, Pluto, I grew up with Pluto and, that kind of thing. And also I chronicle some of the things in the arts that are going on, songs and things like that. You'll see me a lot of times writing responses to other articles where people are writing, people are responding to Kirby Runyon saying, no, it's not a planet. I'll put the address of my blog on the Facebook page. You get that? You're on Facebook? Yeah, so you can see it. And like I said, I also covered New Horizons for Spaceflight Insider. I write about other things for them too. That's a website, and there are still developments with New Horizons because so many papers are being written analyzing that data. Just how much analysis can be done, look at Neptune. Voyager 2 flew by Neptune in 1989, and a researcher just found another moon of Neptune from those old images. So yeah, you can get a lot out of that. So yeah, and I'll put my my blog and then the two sites that I write for, Space Reporter and Spaceflight Insider.
If you want, you can type it up there and you can just hit it with your phone if you want. Make it easier.
Oh, okay.
Should be on the Facebook page.
Yeah,
in
just
general.
Yeah, okay.
For those who are here and those who can't be.
That's http://laurelsplutoblog.blogspot.com.
I'll put the other sites are not. I'm not the only writer. They have many writers. Do I need the HTTP in this or not? That one doesn't have www and probably other people here know why. I don't know. The two lower ones are those are basically their news sites about various space missions, developments in both robotic and manned. I'm not the only writer. Spaceflight Insider tends to be the articles tend to be a little longer than Space Reporter. They're a little bit more in depth. I got into media in the New Horizons flyby because I covered it for Spaceflight Insider, and the articles from the flyby are still there.
Okay. That's Laurel's Pluto blog at blogspot.com, spaceflightinsider.com, and thespacereporter.com. It's about time to leave. We only have room until 10, but thank you all for coming. Join us next month for the third Thursday lecture series. That will be June 15th when Stella Pulo, an Australian-born actress, will come here to discuss her experiences in traveling and performing all over the world. And after that, on July 20th, we'll have Kurt Sass, who is also in Greater New York Mensa, describing his battles with mental illness. So I hope to see you at both events and possibly other future lecture series. And don't forget to let me know if there are any speakers you recommend, or if you yourself would like to speak for us.
I actually have a question about the test for Mensa, because it's been a long time since I took the GRE, but I understand that, I guess on the way, I don't know if it's still configured the same, that with the verbal and the math, that if you had a 1250, you could be in Mensa without taking the Mensa test? Or is that no longer true?
No, Mensa accepts about 200 other tests as prior evidence, as long as you've got a certified copy of your results. The scores needed vary with the year, but
well, I had a
you can check it out from the national
1230.
website.
I was
yeah.
20 points short.
I
You can't make
don't know the
It probably
numbers.
goes by your percentile,
What?
right?
What?
It probably goes by your percentile, but the percentile.
There is a list on the national site at us.mensa.org.
Oh, so it's not up to the local.
No,
Okay.
it's the international
Now,
organization.
this is also, it may be too long ago to
Nope.
sometimes.
That's what.
No,
Really?
they don't expire.
So, but if it says 1250, I don't think they're gonna make an exception.
No, if the number doesn't match, then it's not acceptable, but you can
So
still
we'll
take
Take
the
it again,
test.
we'll take another
You
test.
can
And
take
can
a
you only
different
take the test once in your life?
The Mensa admission test, yes.
Oh,
Yes.
boy.
It's a one-time, it's a one-shot deal.
Wow.
You better have taken like
That's
the
why-
LSAT or something
What?
like
No, I didn't.
or GRE or.
That's why prior evidence
Well,
is
if
so
you took
popular.
the GRE, you
Prior-
must
wait a
have
minute.
taken the SAT at some point.
Oh, I did better on the GRE, actually. So, yeah.
Yeah.
Yeah, no, I knew that, that's like.
Yeah,
So
it's
close.
not a gray area, it's a hard and fast cutoff.
Wow.
Yeah, and there are
There's no
different
atmosphere.
points in time as well as different
What?
examinations with both international Mensa actually disqualifies. You should just look it up.
That they
a little
what?
bit.
I'm sorry,
That they
say that?
disqualify. They say this is too easily studied for. This is
Really?
You know, the parameters or the metrics have changed, and now this doesn't qualify anymore.
Wow.
So
Yeah.
you should just look it up.
There was a span
There's a
of
ton of
time,
them
the
now.
score on the SAT was a certain number, and then for the following years it
They
was a different number.
changed it so much.
And then they
put an
changed the
essay-
test so much that the SAT was unacceptable, but those older scores were still acceptable.
Right, yeah, but
Mhm.
I was like, well, I mean, you kind of fudge it.
No, you can't.
Wonder if-
Consider it a planet without an atmosphere. It's a hard and fast cutoff.
Well, Mercury only has a thin atmosphere. One thing that's interesting, you know, Alan Stern said Pluto is the most Earth-like planet in the solar system after Earth. I think that's
That's great.
fascinating.
At least he said after Earth.
So,
Yeah, after,
so there is possibility of life on Pluto.
there could be microbial life if there's a subsurface
That would be
ocean.
real
Any
cold.
such what?
Would be really cold.
Well, they were thick
But-
fur coats.
No, but they found in hydrothermal vents in Earth's oceans where it's freezing and there's no sunlight, they found microbes, which is what's leading to this. They could be in subsurface oceans because there's that internal heat source. So it's possible. You know, which I think, you know, definitely, like I said, changes what's the habitable zone. You know, it's far beyond just where liquid water can be on the surface. I personally want them to want microbial life to be found, just to kind of stick it to the IAU. It was only 4% of the IAU that voted in this, by the way. I think there's an issue when they say we don't want to go back and readdress it. It didn't come out looking good for them. They got a lot of bad publicity, but you know, I think they should. You know, the best thing would be to say, you know, we're just discovering worlds in our solar system and others. Maybe it's too soon, and we just need to, you know, see what's out there before we make hard and fast classifications. Because it's a spectrum. Even, you know, the stars have a spectrum. You know, there's a spectrum all the way from, you know, tiny asteroids and comets all the way to just the lowest star, where you know, a brown dwarf is now lowest stellar classification. So, you know, it's a spectrum. It's not a hard and fast.
Do you think they would ever actually make planets like they do in Star Trek? Like they have different class planets?
Star Trek actually has a good system, and people have proposed using it. Like a planet that can support life as we know it is called the Class M planet. They've got this intricate system. People have also proposed something like the Hertzsprung-Russell diagram for stars. That, for example, you might want to put Ceres, Enceladus, Europa, Pluto, Triton may also have a subsurface ocean, and Titan, Ganymede, and Callisto. You might want to put those all in a class as ocean worlds, whether they orbit the sun on their own or their moons. Some people make a big deal. Oh my God, moons can't be planets, you know, because if you say everything spherical. And Alan Stern likes to call them satellite planets or moon planets. I mean, they're still moons, but it just distinguishes those ones that are in hydrostatic equilibrium because those are far more complex.
I just asked because I had to come here late. Is this video going to be available anywhere?
Yes, it's going to be on YouTube.
Oh,
And it just cuts out. It's okay.
Yeah.
But it ran out of space or
Well,
battery.
the battery.
Oh,
But
okay,
you were
it's
here
okay.
by the time it cut out, so you'll catch the
Yeah.
part you missed.
Okay, and
Oh,
what will it be under Mensa or under Laurel?
Oh, I think you're putting it on, right?
Yes, I'm
Yeah,
putting it
'cause
on.
it's his. I didn't have a camera, so which is good because at least I know of at least a friend of Chris's, and I think two friends of mine, including Steve Collier, who I credit there, another Pluto, strong Pluto supporter. Steve wanted to be here, but he couldn't make it. Yeah, and that's interesting. All over the world, I meet people online who just are so fascinated by Pluto.
I'm in a Pluto support group. I'm on the
Oh, is that
camera.
fine. If you're on Facebook, there's so many of them. It's kind of, you know, the Pluto resistance. You know?
Pluto resistance movement.
Yeah.
Also Popeye's dog, right?
Oh, that's Pluto, not Pluto.
Oh,
Make the
Pluto,
mistake.
I thought it was
That's
Pluto.
with a B and not a
Mickey
no,
Mouse's
no,
dog.
Oh.
Whoops, I'm caught on the keyboard here.
Oh.
Thank you so much. Well done.
And from
Me,
the
here's the,
blog, you know, I think my email is there, you can
Oh, good,
contact
I'd
me.
like to contact you if you don't mind.
Yeah.
Especially because I'm actually a musician.
Oh, really?
Yeah.
Sorry, I'm just gonna change, put on my sandals instead before you take general.
I'm not sure, I'm gonna contact you if you don't mind.
Well, oh, sure, absolutely. What's your name?
Raquel.
Okay. Thank
Let
you.
me
Yeah,
take that, if
absolutely.
you don't
Yeah,
mind.
just need to make some 2 more additions.
We actually have like a rapid response team with people that, you know, whenever people write these, you know, anti-Pluto, and they write very virulent things
Actually,
like,
I have
Pluto
some
will never be a
serious
planet
feedback.
again, you
So
know.
excuse me for
Um,
one moment.
So, you know, we contact each other, you know, this needs a response, this needs a response. You'll
Yep.
see this on my Facebook.
Thank you very much.
Thank you.
You're
Have a
welcome,
good
thank
night.
you for coming. Do you have a card or something?
Oh,
I can-
right, yeah. Why am I padding where there are no pockets?